Hello everyone, welcome to day 3 of chain rules. So today we are focusing on chain rule with one additional derivative rule, which is the natural log. So this one's not too crazy. The derivative of natural log of x is just 1 over x. Not too bad. Okay, so what's going to make it a little bit more complicated is when we have to mix it in with product rule, quotient rule, or chain rule. If we have to do multiple things, that's what's going to make it a little bit more complicated. But because it is natural log is one of those special functions where it also has properties to it that'll actually make things easier for us. So if you remember your log properties, there were 3 of them. So if we were taking of the log of something with an exponent, you can move the exponent to the front. If you're taking the log of 2 things that are being multiplied, you can actually split them up into 2 separate logs that are being added. And if you were taking logs of something that was being divided, you can split them up into 2 separate logs where they're being subtracted. So I keep saying log properties because natural log, ln, is the same thing as a log. So we can actually do all of these log properties with natural log as well. So it would just change all of our logs into ln's. Okay, but we want to be able to do this because if we're taking the derivatives of these things and we have stuff being multiplied or being divided, rather than using the product rule or quotient rule, we can just split it up because it's way easier to find derivatives of stuff that's being added or subtracted than if they were being multiplied or divided. So that's the nice thing about natural logs. Oof, just had to edit out the school bell ringing. Anyways, let's do some examples. Alright, so first one, we'll start off nice and simple. Let's find the derivative of -2 times the natural log of x. Alright, real simple here because when we find the derivative, y prime, we've got a constant multiplier. So it's just a number being multiplied to the other stuff. So constant multipliers, they just stay there. So -2 will stay there. But then the natural log of x, the derivative is 1 over x. So my final answer is just going to be -2 over x. Cool. Easy peasy. Okay, slightly more difficult example now. So let's go with y equals natural log of 2x. Okay, so for this example, you may or may not see the parentheses written depending on the book, depending on the problem. It's not necessary for the parentheses to be there, but I put the parentheses there because I want you to notice something specific here. If there's parentheses here, and this is kind of how I kind of trained you for this, there's stuff inside the parentheses that's more than an x. So if it's more complicated on the inside of the parentheses, this is when we would need the chain rule. So just a quick reminder, for chain rule, we are taking the derivative of the outside, leaving the stuff inside exactly the same, and multiplying it by the derivative of the inside. So in order to find my derivative of y here, y prime is going to be the derivative of the outside. So the outside was natural log of parentheses. So the derivative of natural log is 1 over whatever. So the stuff inside the parentheses, we said, stays exactly the same, so it's still going to be the 2x. Then we're going to multiply that by the derivative of the inside. The inside stuff was 2x, so the derivative of 2x is just 2. When I multiply that, I end up with 2 over 2x, which just simplifies to 1 over x. Cool. Okay, so the derivative of the natural log of 2x is just 1 over x. Which is interesting because the derivative of just natural log is also 1 over x. But anyways, I want to show you now another way to do this. So both of these ways are correct. It's just whichever you prefer. So first, I would like you to remember this is our original problem, natural log of 2x. I can actually use one of the log properties to rewrite this. Because if I'm taking the natural log of 2x is 2 things being multiplied together. So it's technically the 2 being multiplied by the x. So I can use the second log property to split this up into 2 separate logs being added. So I can rewrite this as natural log of 2 plus the natural log of x. Okay, so now I have 2 logs being added, so if I find the derivative of this, then the sum rule just means that I'm going to find the derivative separately of natural log of 2 and natural log of x, and then add them together. So here, the natural log of 2 has no x's in it. Also, if you do natural log of 2 in the calculator, it's just some decimal. So really, natural log of 2 is just a constant. It's just a number without any x's, so the derivative is 0. Okay, and then I'm going to add this to the derivative of the natural log of x, which, according to our new derivative rule, is just 1 over x. So when I add that to 0, I just get 1 over x again. Done. Easy. So, to me, they are about the same level of difficulty, but it's up to you, whichever you prefer. If the log rules work, they usually make things a little bit easier. Okay, so let's do another example. This time we've got f of x equals 3 times natural log of x squared plus 1. So again, I've got stuff inside the parentheses, so this is a pretty good indicator that I should be using chain rule. I'm going to see if I can use log properties first, but according to my log properties, I don't have any rules about taking logs of stuff where they're being added on the inside, so no log properties apply, unfortunately, which means we can only use chain rule. Okay, so inside outside. The stuff on the inside is the x squared plus 1. The stuff on the outside would be everything else. So the 3 natural log stuff in parentheses. Okay, so finding the derivative, or f prime of x, we're taking the derivative of the outside. So we got 3 there, which is just a constant multiplier, so we can just leave that there. Natural log of stuff, so the derivative of the natural log would be 1 over the stuff. And the stuff on the inside of the parentheses was the x squared plus 1, so that'll stay the same in there. And then we are multiplying by the derivative of the inside, which is the x squared plus 1. So the derivative would be 2x. Alright, so multiplying this out, I'm going to end up with 6x on top, x squared plus 1 on the bottom, and I don't think anything simplifies anymore. So that's it. Not too bad. So continuing on. Okay, next example. Slightly more difficult now because we've got y equals x ln x, which means we have 2 things being multiplied, the x with the natural log of x. So if 2 things are being multiplied, then we would need the product rule. So I'm going to find the derivative of each thing. X, the derivative is 1. ln x, the derivative is 1 over x. So product rule, we're doing our little like cross multiply thing. Here we go. So y prime equals, so 1 times the ln x plus x times the 1 over x equals natural log of x plus 1. Cool. That wasn't so bad. Okay. So this next one, I kind of want to use as like a way to see like what kind of rules we should use, because up till now we've done like chain rule, we've done product rule, we've done log properties, all this good stuff. So here we are looking for the derivative of the natural log of x cubed. So first, I see parentheses with complicated stuff inside, so maybe chain rule. But this is also natural log, so again I could try to use log properties to make it simpler. That would be nice too. I think if I use log properties, if I have an exponent, that would look like this first log property here with an exponent here. That would just move to the front and be multiplied with the natural log. So if I rewrite this, it would look like 3 natural log x, which I think would be easier, because rather than doing chain rule, then I just need 3 is not even, I don't even need product rule. I have 2 things being multiplied, but the first thing is just a 3, which is a constant. So this is really a constant multiplier rule. So here, the derivative, now that we've rewritten it, we didn't need product rule, we didn't need chain rule. It's just going to end up being 3, because that stays as the constant multiplier. And then the derivative of the natural log of x is just 1 over x. So final derivative is just 3 over x. Easy, got this. Okay, so let's keep going then. Let's do the natural log of the square root of x plus 1. All right, a little bit more complicated. But again, let's remember radicals, like, not the greatest thing to take derivatives of, but we can rewrite it using an exponent, and that usually makes things easier. So let's do that. Let's do the natural log, or rewrite this into the natural log of x plus 1 raised to the 1/2 power. And so kind of like before, if I'm raising something to a certain power, I can use the log properties to move that power out front. So this is really the same as half times the natural log of x plus 1. All right, not bad, because that half is just a constant, so I don't need the product rule. So that's just a constant multiplier, so it'll stay in front. But then I still do have the parentheses with the x plus 1 inside, and the x plus 1 doesn't fit in with any of the log properties, so that one I actually do need chain rule for. So the inside would be the x plus 1, and then the outside is going to be the half with the natural log of stuff. Okay, so finding the derivative of this then, the derivative of the outside is going to be 1/2, and then instead of natural log, the derivative of that would be 1 over whatever was in the stuff, which for us was x plus 1, and then multiply that with the derivative of the inside, which is just 1, because the derivative of x plus 1 is just 1. All right, well, then multiplying these things together, I just have the derivative is 1 over 2 times x plus 1. Or if you really want, you can rewrite this as 1 over 2x plus 2 if you distributed it out. I don't care. Both ways would have worked. Done. Not too bad. Okay, last example. Also the craziest one. But because it's natural log, it's not actually going to be that crazy. So just looking at it, I'm like, oh my gosh, I got natural log of like, x times this x squared plus 1 squared all over the square root of 2x cubed minus 1. Why? Why? Why would you do this to me? But, okay, let's use those log properties because I've got things being multiplied, I've got exponents, I've got things being divided. Let's use all of the log properties. So I'm going to rewrite this as the natural log of x plus the natural log of x squared plus 1 squared minus the natural log of the square root of 2x cubed minus 1. Because I've got the, on top, I've got the x being multiplied with this stuff. So that's that first, the log property with the things that are being multiplied, you can rewrite using the plus sign. And then anything that's being divided just goes with a minus sign in front of the log. But the log still has to stay there, so that's like the key thing to remember. When you split it up, there's more logs now. Okay, but that's fine. Then I also see I have an exponent here and also a square root here, so I can rewrite those using the log property with the exponents. So let me just start off with this natural log of x plus, and then I'm going to move that exponent of 2 up down in front. Natural log of x squared plus 1 minus, and then that radical is really a square root, which is really an exponent of 1/2, so that can move to the front. And then leaving me with the natural log of 2x cubed minus 1. Okay, so this looks much more manageable now. When I find the derivative, I know for this middle term, I'm going to have to use the chain rule because I've got stuff inside the parentheses. So the inside is going to be the x squared plus 1, and the outside is going to be 2 natural log of stuff in the parentheses. Same thing with this last term. The inside is going to be the 2x cubed minus 1, and then the outside is going to be the 1/2 natural log stuff in the parentheses. Okay, so when we find the derivative, I'm just going to go part by part. I'm going to start off with this natural log of x. The derivative is 1 over x. Easy. Okay, next. Now I'm going to look at that middle term. So the 2 natural log x squared plus 1 will require chain rule, so it's got a plus in front. And then the derivative of the outside is the 2, a constant multiplier of 2, with the natural log. So we'll use the natural log derivative rule. It'll just be 1 over whatever was inside the parentheses, so that'll be the x squared plus 1. And then multiply that by the derivative of the inside. The inside was x squared plus 1, so the derivative of that would be 2x. Okay, and the last part, we've got the minus 1/2 natural log of 2x cubed minus 1. So there's a minus sign, and then using my chain rule, the derivative of the outside would be 1/2 as the constant multiplier times the derivative of natural log of stuff in the parentheses. So it'll be 1 over the 2x cubed minus 1. And then we're going to multiply that by the derivative of the inside, where the inside was 2x cubed minus 1. So the derivative would be 6x squared. Okay, so I just did all the chain rule and everything that I needed to. Just need to simplify from here. So the 1 over x stays. If I multiply out my next term, I'm going to get plus 4x over x squared plus 1. And then the last term I have a minus. Looks like multiplying this out, I will have the 6x squared on top, the 2 and the 2x cubed minus 1 on the bottom. But I think that simplifies more. So my final answer, I think I'm going to end up with 1 over x plus 4x over x squared plus 1 minus 3x squared over 2x cubed minus 1, because the 6 and the 2 can be reduced. All right, and that's it. That's my final answer as the derivative. Cool. That's it for this video. Thanks for watching day 3 of chain rule. One more day left from here. I'll see you next time. Bye.